Hello mathematicians, we'll now have a look at surds and their arithmetic. Now I think for many of you this will be reasonably familiar from Year 10, but if you're like most of us it will need some brushing up. So let's do a little bit again of background. The first bit is a minor point, but by definition this symbol, square root of x, means the positive square root of x. And I just want to point out that that's slightly different, just in interpretation, to when we say take the square root of something. So if we say take the square root of something, we mean get the numbers that multiply together to give that answer. So we saw in completing the square that we have to say plus or minus. But if we actually write square root of x, it just means positive square root. We would actually have to write plus or minus root x if we wanted to indicate both of them. Square root, of course, only exists for positive numbers, for x greater than or equal to 0. And a surd is just any root of a number which can't be expressed as a rational number. So as we said previously, that means it can't be expressed exactly in the form a over b. These rules about surds you'd be familiar with, that the square of a square root takes you back where you started, and the square root of something squared takes you back where you started. The product of two square roots is the square root of the product, and the square root of a quotient is the square root of the numerator divided by the square root of the denominator. It's often easy to forget these things, but they can make a real difference to solving problems. If we take that property here, that square root of a times square root of b is square root of ab, it also lets us simplify surds. And that method involves taking a number that we want to see if we can write more simply, or a surd we want to see if we can write more simply, and checking whether there are factors of that number under the square root sign, one of which is a perfect square. So that's the only condition under which it will work. So in this example, 75 is 25 by 3, and 25 is a perfect square. It's also 15 by 5, but neither of those are perfect squares, so they're no good to us. But when we write it like this, that means that we could then write it separately as that. We can take the square root of 25, so this would simplify down to 5 root 3. Now this just becomes more familiar with practice, no more than that. As in addition to those properties that up above, all the usual algebraic relationships apply. The things that we did in the last topic, we can do in this topic. So binomial products, expanding brackets, squares of binomial, difference of squares, all of those things, expansion of cubes for that matter, they all apply to surds just as well. Okay, so let's have a quick look at these examples. I'll go through them really rapidly. So square root of 36 we know is 6. Square root of 6x squared is the square root of 6 times the square root of x squared, which will end up being just that. This one, 2 root 18, so if we think of 18, that's 9 by 2. So that's equal to 2 by 3 root 2, which is 6 root 2. And the cube root of 8x cubed is the cube root of 8, and the cube root of x cubed. This one here, we can't do a subtraction, we have to get them to the same surd if you like. So root 50 is 5 root 2, root 18, 3 root 2, so this is equal to 2 root 2s. 3 root 75, well again, that will be 15 root 3 plus 5 root 3, so that's 20 root 3 altogether. Remember, we can also, can't think of a situation where you would often need to do it, but take that number back under the surd sign. So for what it's worth, 20 root 3 is equivalent to root of, and all under the sign, 20 squared, which is 400 plus 3, so it's equivalent to root 403. Okay, root 7 plus root 28 is root 7 plus 2 root 7s. As I said, you might need to check these a bit more carefully, but I'm just racing through them. Root 54, so what have we got that goes into that? 9, so this is 3 root 6 minus 2 root 6, so that's just root 6. Down here, we recognise this as a difference of squares, a plus b, a minus b, so that equals a squared minus b squared, so that's 2. You'll get very used to those brackets. And this one here is our usual expansion of brackets. Square of the first, so that will be 4 times a, plus the square of the second, so that will be 1, and this sign, minus, twice their product, so that will be 4 root a. Okay, so you could try these ones in 2C.